So there's an example written on the other board. A long division problem. Probably looks like something you did around 4th grade, maybe?
Yeah, we learned it like
third. I was going to say 3rd or 4th grade. I don't remember. You put them in the house, right? The difference now is we're going to have these big polynomials that we're dividing by. So I'm going to put an example here, and we're going to set it up on the next page so that it's there's enough room. So we'll have something like, remember we've already added, subtracted, added, subtracted, and multiplied. We factored, which is actually a form of division, but now we're really going to divide. Plus x minus 1 divided by x squared plus 2x minus 1. So remember there's a couple ways you can write it. Over here I've got 5 divided by, or 127 divided by 5. So that's the same thing as if I had written it 127 divided by 5. I can also write it as a fraction, right? You would do the 2x to the 4th plus x cubed plus x minus 1 over x squared plus 2x minus 1. Right?
When you like that, can you just like,
well, it's going to be given to you either way. You need to know how to put this into a division problem like the 5 into 127. Now, there's one thing I need to tell you before we start that will throw your whole answer if you don't do it. And we've kind of talked about these before. They're placeholders. So placeholders do exactly what it says that it does. It holds the place of something. So look at your expressions there. Do you see anything that's missing?
No.
So, and by missing, look at it. I start with the 4th power. Then I go 3, the 2nd power. So if you're missing anything, you need to make sure that whenever you set the problem in, you come in and you hold the place of the 2nd power with a 0. Okay?
Wait, so anything that's in one of the equations not in the other one?
Anything, start with your biggest exponent, so this is 4, and make sure 4, 3, 2, 1, and constant are there.
So everything has to be there starting at
Yeah, starting with the biggest. Then I look at this one, 2, 1, constant, I'm good there. Okay? Do we understand placeholders?
X.
You don't need to understand why yet. You'll see in a minute. Just understand to do it right now.
So everything like
All the way down. Start with the biggest.
So if we started at 7,
we would have to have 7, 6, 5, 4, 3, 2, 1 constant. Yes. Yes. Every exponent from the biggest down needs to be there. Okay? Just like when we were graphing in standard form, if that b was missing, we plugged in a 0 for b. Same concept. We need to make sure we hold the place. Yes. All right. So let's set it up. On the outside, let me write this down. Plus 2x minus 1. On the outside goes what follows the division sign. So I have, and you'll want to keep this neat. That's going to be the key to this, is how neat you are, okay? X squared plus 2x minus 1 into
What is that?
2x to the 4th plus x cubed plus 0x squared. There's my placeholder. And now what we're going to do is we're going to make sure that our columns stay the same. I've got a 4th power column. I've got a cubed column. I've got a squared column, a power of 1 column, and a constant column. Okay? Now, go back to the example that I have written on this board, 5 into 127, and tell me, rewind back to your 3rd or 4th grade self, what is the first thing that you do when you look at this?
you see if it goes on 12.
You see how many times, what do I need to multiply this by to get this, right? 2. Right? 2.
Yeah.
Where do you put it?
And then
Up top, above, over the 2. So now, I'm going to apply that same concept here, okay? I'm going to look, and if you have colored pencils, this is probably a good day to use them. This time I'm only looking at first terms. First terms every single time, okay? What can I multiply this by to get this?
Probably 2x squared.
2x squared. Does everybody agree? Okay. This time I'm going to keep my columns lined up. So I'm going to go to the column with the power of 2. Dawson, do you see why I needed that power of 2 column, that placeholder now? Because now I need that column here.
Because it's 2 squared, because it's square math.
Because I'm keeping columns lined up. Anything with a power of 2, I'm going to be in this column.
Well, we're,
Power
so we're
of
looking
3.
at the first one, but it's gonna go
Yes,
like.
yes. Okay.
And then you do the second one.
Wait. Nope. You only look at the first term.
So
That is
2x
the first
minus
step.
1,
Where
none of
you
that.
put the
That's
2 in this equation, this division problem, that's what we just did.
I know. I'm
Okay.
saying, like, you do anything
Nope.
with 2x.
Not
minus
yet.
1.
Nope. All right. What do you do here now? 2, you gotta multiply. We multiply here, right? Does everybody agree with that? We multiply there. When you multiply it, where do you write it? Under it. It goes right there, right? We're gonna do the same thing. We're gonna take this number up top, but this time it's got to multiply to everything outside. Okay? So, 2x squared times x squared is what? 2x to the 4th. Keep it in the right column. 2x squared now times 2x is 4x to the what? 3rd. It's positive. I'm basically distributing that 2x squared through. And then 2x squared times negative 1. Is anybody confused? Exact same step we did, only now we have polynomials we're doing it to. Okay, walk back over here. I multiplied through. I write down here, what do I do now? I subtract, right? Minus, and I get 2. So over here I'm going to do the same thing, but now you'll see why we subtracted polynomials and spent a day doing that. Because I need to subtract this whole thing.
From just that first thing.
So, now I have this minus this. So I set myself up to a same change everything kind of situation because I'm subtracting all of those. Are y'all, do you understand?
Yeah, should we write
Okay.
that out to the side that separately with the equation?
It's up to you. I always do it here. I'll generally go ahead and change. I'll do same, change to make it easier. But what you are doing is subtracting, okay? The first term should always cancel out on you when you subtract. Because we asked ourselves, what do I need to multiply to make it? Cancel. What is x cubed minus 4x cubed? That's right. What is 0x squared plus 2x squared? You do. You're absolutely right. What do you do now?
Drop down the x.
Drop down the next term. Right? So I'm going to drop down the next term, which happens to be an x. And now, the whole process starts over, right?
Oh my god.
What do I multiply 5 by to get 27? And it goes up here.
Okay.
Okay? Back to first terms again.
Wait, why don't you bring down the -1?
Because you only bring down one number at a time, so you only bring down one term at a time. All right? What do I multiply x squared by to get negative 3x cubed? Until you're done. What do you multiply by? That's why it's called long division. Negative 3x. I go to the x column. What do you do now? Now we multiply. But we multiply to everything. Negative 3x times x squared, and I'm emphasizing the negative because you got to make sure you take that negative 3x. Negative 3x cubed Negative 3x times 2x
Negative 6.
squared. And negative 3x times negative 1, positive 3x. Now what? Subtract. Yes. What do you, guys, what do you multiply this, actually, this by to get this? You're always looking at first terms. All right. Let's subtract here, which means same, change, 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 change. If your first ones don't cancel out, you've done something wrong. Because you asked yourself in the beginning, what do I need to multiply by to get that? Okay. 2x squared and 6x squared gives me 8x squared. X and negative 3x gives me bring down the next one. You're absolutely right. Drop down the next term. And the process starts over again. This is so repetitive that you do a couple and there's no way you don't get it because you're doing the same thing over and over and over and over and over.
Wait, same as we get. Since you same, change, then technically we're just adding it.
Mm-hmm.
This is
Yes. Up top, you're always looking, what do you multiply x squared by to get negative 3x squared? 3x cubed, I'm sorry. Same thing, I'm fixing to do the same thing again. What do I multiply this by to get this? 8, right? Just 8. It goes in the constants column. And I'm going to multiply around, all the way around. 8 times x squared is 8x squared. 8 times 2x, 16x. And 8 times negative 1, negative 8. No, not with the variables. Okay. Same, change, 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 change. First one should cancel, and they do. Negative 2x and negative 16x is negative 1 and 8, 7.
Why would it just be 14?
That is the remainder. What'd you ask, Ben? All right, so look, we've got to interpret this remainder, okay? Now, before when you've divided, you've probably thrown a decimal in there, started adding zeros to get decimals, right? Or you just wrote R equals. Yeah. But what is another way? Over here, when we multiply around, we get 25. Our remainder is 2. What's another way to use that remainder?
fraction.
As a fraction, right? You would do 2 over what's on the outside, right? And I can essentially add that to it. We're going to do the same thing. We're going to take our remainder. And how do I know that that's a remainder? There's nothing I can multiply x squared by to get negative 18x. It doesn't go in anymore. So I come over here and I say plus. I take that remainder and I put it over what I divided by.
So do you write it like so then is your answer like 2x?
The answer is everything up top now. 2x squared minus 3x plus 8 plus negative 18x plus, yeah, you don't have many because they do take a while.
And we just leave it like that? Like we don't
That's the answer. Let's do one more together. One more together.
Okay. Is that about how long all of them are, or there's some that like get a lot?
Some are longer than others.
They're not different.
Is this all average or short? Is this average or not?
Average. I mean, you can tell pretty much how many steps you're going to have. I mean, when you look at it, well, This is average.
Sometimes they not have like extra numbers.
Yeah. Let's do x plus 2 into x cubed minus x squared plus 4x minus 10.
Oh, this is mine.
All right, so step 1, I'm going through the same thing. What do I multiply x by to get x to the third? X squared, right? So I go to the squared column.
Why do you never start with Oh, okay.
Are you with me, guys? All right, what do you multiply x by to get x cubed? Okay. Now multiply around, but multiply to everything. So x squared times x is x cubed. And x squared times 2 is 2x squared. I'm subtracting, but I'm subtracting everything. The first ones are gone. Negative what? 3x squared. Bring down the next term. Am I going too fast? Okay. X times what gives you negative 3x squared? Negative 3x. Negative 3x. What do I do now? Multiply. Negative 3x times x. And negative 3x times 2. Negative 6x. All right. Same, change, cancel. 4x and 6x gives me 10x. See the repetition here? Holy cow. Bring down the next term. Same thing again. X times what gives me 10x? 10 up top. Multiply around. 10 times x is, and 10 times 2 is, I got the sniffles. Same, change, cancel. What do you get? Negative 30. What is negative 30? The remainder. How do I know that that's a remainder? There's nothing else to do. There's nothing else to multiply x by to get negative 30. So I say plus remainder over quotient.